All right, so we are starting 7-6. This is the last lesson in Chapter 7. It is all about transformers. JK, transformations. Ha ha ha. Transformations. So, we're taking shapes and we're transforming them by dilations. How many of you have ever had your eyes dilated? Yeah. So when your eyes are dilated, do they get bigger or smaller? Bigger. So is that an enlargement or a reduction?
Enlargement.
And when they go back to normal, what's that?
Reduction.
Right. That's exactly what we're doing. Okay? So a dilation is either an enlargement, so it either enlarges or it reduces. Do what?
Yeah.
Uh-huh. Okay, so we have dilations. When we're talking about dilations, we have what we call a pre-image and an image. The pre-image is what I call the OG. It's the original. It was here from the start. The image is what it becomes. Does that make sense? The pre-image is what it was to begin with. The image is what it becomes. So, these are all similarity transformations. They are not congruent. They are similar. Okay? All the dilations are fixed around a certain point called the center of dilation. So, in this example, your center of dilation is your vertex, which is just 0, 0. Okay? So, if I tell you that this one is the OG, this triangle is the OG, what does this triangle become? The image. So it's from where it starts to where it comes. Okay? So we're going to use a scale factor to determine if these dilations are similar. A scale factor is now going to be recognized with the letter K. K. Just like some people, just like the famous mathematicians use M for what? M for slope. Slope. People are like, well, why is K for scale factor? Because it is what it is. You don't argue with the old men that made this up, right? Okay. I mean, really. Really. I had to take this course in college, and it was all about the people who came up with all this stuff, and they were all old men. Okay? So, K is your scale factor. Now, when you're taking the scale factor, it's going to be backwards than what you think. It's going to be the image over the original. So what it becomes goes first, and then the original goes bottom. And you only have to have one ratio. Okay? So if I could count this distance, if I could count it, let's just say, for example, it's 10, and this is 5, then the scale factor of this example would be 10 to 5, which reduces to 2. So the scale factor is 2. Okay, so you kind of work backwards on that part. So there's two types of dilations. There's an enlargement, like we've discussed, and a reduction. If it's an enlargement, the scale factor has to be greater than 1. Yes?
If we just put like the answer and then K, could that be just saying that that's the scale factor?
You need to put K is equal to. What's a scale factor that is an example of being greater than 1 as a fraction? 9/5. What else? 4/3. Right? Anything greater than 1. Yes. Yes. Okay. Okay. Now, if it's a reduction, it has to be between 0 and 1.
2/3.
2/3. 1/3. 2/3. Oh, we already said that. 1/4. 3/4. 7/8. Okay. What happens What happens if the scale factor is 1?
They're the same.
Nothing changed. The scale factor is 1, nothing changed, okay? So, if it's greater than 1, enlargement. If it's less than 1, reduction. And here's how you could think of it. If it's a reduction, then it's dividing by something, right? So that's why it's okay for the k to be 1/2, because you're taking your original and dividing it by 1/2 to get to the new. If you have an enlargement, let's just say, for example, k is 2. You're taking the original and multiplying it by 2. Does that make sense?
No.
Okay.
Oh my god.
Let's keep practicing. Let's just practice. Okay. Now, guys, I really just need you to just not complain. No, not freak out. It's not that bad. Just not complain. If you can't see a line, just tell me and I will help you out. Okay? All right. So, example 1. Determine whether the dilation from what to what?
A to B.
A to B. So A is your OG. B is the new deal. Is an enlargement or a reduction, then find the scale factor. Okay, so here's A. Does everybody see A?
Yes.
Okay, because we struggled with that last period. It was amazing. A to B. Without even finding the scale factor, what is it? Is it getting bigger or smaller?
Oh, reduction.
It's a reduction because it got smaller. So K has to be in between what?
0 and 1.
0 and 1. So take your new image, which is what letter?
B.
B, and put it over A. Here's the deal. You always want to find something that you can count. For example, I don't want to count these two sides because I'd have to use the distance formula. But I can count the tops. Okay? Be very careful when counting B. I'm going to tell you that it's exactly 1/2, but if it's not exactly 1/2, or I don't tell you it is, you might have to do the distance formula. Okay? So, what's B? What's the distance of B?
3.
3. And the distance of A? So, we're counting just the top. 1, 2, 3, 4, 5, 6. So, K is 1/2. Okay? Now, I know this tells you the answer, but I want to explain and not just let you read the answer. Okay? From A to B, did it get bigger or smaller?
Smaller.
What?
Bigger than A to B.
A to B. It's an enlargement.
Oh, that was
So are we going to divide by a scale factor or multiply? Multiply. So it's got to be greater than 1. You can either count this side to A and this side of B, or you can count this side. Doesn't matter. They're both going to be the same. So count B first. What's the distance of B? 4. What's the distance of A? That's it. No, I want it as that scale factor. Okay? Okay. All right. Will you do 1A and 1B? Okay, if you can't see, because look, here's this baby triangle. Here's this big triangle. You see it? Does everybody see it?
1A.
Oh, I kind of drew this wrong. Y'all know I'm not a good drawer. But this goes here, to here, to here. I mean, y'all have exactly what I have. Mine looks exactly. Y'all have. I picked up the same exact copy that y'all have. Yeah. Still going A to B. A to B.
So we say either reduction or alignment in this.
Scale factor. Yep.
These people came to my house yesterday and ripped out my mom's bathroom because my mom is full of grass.
Okay, well, let's pause on that conversation. And let's finish our lesson. Then you can tell me that. Okay. Okay. All right. So, Lakeland's bathroom yesterday got a reduction. Okay. Number 1A is an enlargement with a scale factor of 5 to 4. 1B was a reduction with 1 to 3. Now, how many of you counted the side right here? Nobody? I would have. But then someone last period was like, well, can't I just count the bottom, which is 1 to 3? I was like, oh, yeah, that's smart. Good job. But either way, it still reduces. 2 6 reduces to 1/3. Same thing. Okay. All right. We're not done. I put these examples here to show you so that we did not have to do this example. Okay? All right. So let me explain. So all we've done is determine the dilation and the scale factor. Now you're going to have to verify if a dilation is actually a similarity dilation, which means, in example A, here's the original 3 points. Okay? So, A to B to C. Do you see it, the big triangle? Mm-hmm. That is your original, okay? And then they give you what the image is, which is this smaller one. They don't tell you what the scale factor is, and they want you to determine if those two triangles are similar. Well, in section 7.3, we learned 3 tests for triangles. What were they? Side, side, side. Angle, angle, and side, angle, side. Okay? Well, this one, I would prove by side, angle, side, because they're both perpendicular. So angle C and angle Z are both 90 degrees. So from there, I would find the scale factor of the sides and see if they're the same. So they take X to Z, which is right here, and they counted 1, 2, 3, 4, 5, 6, which is where they got 6. And then from A to C, they got 9, and it reduced to 2/3. Okay, so they did the bottom. Now let's do the side. Y to Z is 4, B to C is 6, which reduces to 2/3. So they have 2 proportional sides and a proportional angle. Therefore, by side, angle, side similarity, these 2 triangles are similar. Yes?
When we prove that, do we have to write distance like they did?
I don't know. I'll get there. Okay, however, here's the bad news. They're not always going to be triangles. And they're not always going to be where you can count them, countable.
What are they going to be?
They're going to be like this, where they're slanted, and you have to do the distance formula 8 times.
8 times.
Okay? These are quadrilaterals. Okay, so now listen. We do not know a shortcut for quadrilaterals. So we'd have to show that JM is proportional to PS. JK is proportional to PQ. KL is to QR. LM is to RS. I am showing you this example so we don't have to do it. Notice, they did all of that for us. Okay? Hold on, let me finish, please. Okay, so now you have to find the corresponding sides, which I just told you about. Did they all come out to be the same thing? Yes. So are these 2 images similar? Yes. So since all of these are corresponding, these 2 are similar. I just want you to see that. I want you to see that if you had to, it could be done. Wouldn't be fun, but it could be done. Okay? All right. Yes. Yes.
So we're doing that because, like you said, they're uncountable because, like, it's half of the square.
Right. Well, it's uncountable because you can't just count 1, 2, 3.
Okay, but, like, go up a little bit. Like, that's half of the square. Like, where A is.
It's not. My pen just went out further.
Okay.
It actually stops on A. My pen just went out further.
Okay.
Okay? All right. So what I actually want you to do is I want you to try 1, 2, and 3. Now, on number 3, it was really hard for me to see this. It looks like this. Do you see it? From here to here, to here, and then this one. You see it? Okay, and then this one stops here and here. And then 1, you can actually count straight across where I'm showing you. Okay, so this is what I want you to finish. Are y'all listening? I want you to do 1 through 5 on this page I'm on right now. 1 through 5. All you're doing is showing reduction, enlargement, scale factor. Then if you flip the page to the very, very back, I want you to do 1 through 4 right here. Okay? Is that doable? Thank you. And these two, literally all you're doing is telling me, did it get bigger or smaller? That's it.